Falling ball. A ball is dropped from rest at the top of a 420 meter tall building. The ball falls freely until it reaches a speed of 60 meters per second, then reaches terminal velocity. How long does it take for the ball to reach the ground? First thing we've got to do is fill in the blanks. So just of all the stuff that we know from the problem. The initial position is 0 meters and the final position is 420 because the building's 420 meters tall. So we're going to start at t equals 0, in which case the initial velocity is 0 because whenever you're dropping something, the initial velocity is always going to be 0 until you drop it, and then acceleration is going to take over. Acceleration due to gravity is going to take over and pull it on down. The acceleration of free fall is 10 meters per second squared. The ball reaches 60 meters per second at the end of the free fall segment and stays at 60 meters per second for the rest of the free fall. So we can already go through and plug it in. A equals 10, then we reach our final velocity, and that velocity is going to carry on over to the end of the segment. Now we'll apply equations one by one to fill in the remaining blanks. There are always multiple ways to go blank by blank and fill in the segmented motion diagram. We will mention the multiple options at each stage, and then we're going to have to choose one path to take throughout the problem. You're going to get full credit no matter which order you fill in the blanks. So we can use A equals delta V over delta T, which is our average acceleration, to solve for delta T in the first segment, and then use delta X equals the average velocity times delta T to get our displacement, delta X. There are other options, but this will be the easiest. Just remember that in using these equations, it only works for the average. So here are the solutions. You can pause this and double check your work. We get the position at the end of a segment by adding the position at the beginning of the segment to the displacement during the segment. We get the time at the end of a segment by adding the time at the beginning of the segment to the time interval during the segment. Okay, so we've got 0, 6. The time interval was 6 seconds. Since the ball stops accelerating at position equals 180 meters, and the ball reaches the ground at position equals 420 meters, we can deduce that the displacement for the second segment is 240 meters, the final minus the initial. We get the time at the end of a segment by adding the time to the... I said that already. The average velocity for the second segment is 60 meters per second because the average of 60 and 60 is 60. We can then use our displacement equals our average velocity times the time interval to get the time it takes for the ball to fall the rest of the distance, which is 4 seconds. Add this 4 seconds to the time for the first segment to get a total time of total time for the fall to be 10 seconds, which is the answer to the question. Here are 3 graphs of motion. The first segment is shown in blue, where the ball travels 180 meters in 6 seconds, going from 0 to 60 meters per second. The second segment is shown in red, where the ball goes at a constant 60 meters per second for the last 4 seconds. Notice how smooth the position graph is. There are no kinks or corners. It's just a nice, smooth transition. If you're asked to write a narrative, it means tell a step-by-step account or story of how you solved the problem. This narrative needs to cite specific equations that were used, substitutions made, and results of the math, but does not need to actually show your mathematical steps. Here's an example of a narrative from solving this problem. I first used A equals delta V over delta T with a free fall acceleration and delta V of 60 meters per second to get a time of free fall of 6 seconds, using delta X equals V av times delta T, where V av equals 30 meters per second, the average of 0 and 60, we find that the ball free falls 180 meters. That means the remaining 240 meters is traveled at a constant velocity of 60 meters per second. Again, using displacement equals average velocity times time interval, we find this takes another 4 seconds. So the total time to fall to the ground is 10 seconds. That's it for number 1.